Okay, so I'm going to start with another quadratic equation. Now, this is our parent function up here is y is equal to x squared. And I'm going to go ahead and graph it just because I want you to see it on the graph. 1, 2, 3, 4. 1, 2, 3, 4. Okay, this is our parent function. Okay, this is our function y is equal to x squared. All right. Now I'm going to talk about our next quadratic equation, and I'm going to give you the quadratic equation y is equal to, let's do x squared plus 2x, and we're going to subtract 1, okay? Now, we want to find our axis of symmetry. We want to find our vertex, and we want to find our domain, and we want to find our range. Okay, now this is a happy parabola, so we know our vertex is going to be our minimum. Okay, so that means our vertex is going to, or our parabola is going to be a U-shaped instead of a frowny face. Okay, see, I'm drawing a little frowny face, so that means minimum. We're going to have a lowest value. Okay, now the way that this comes into play, so I'm going to go ahead and graph this. I'm going to go to my calculator, and I'm going to go to y equals, and I'm going to clear what I have in here. And I've got x squared, and this is plus, we said 2x, and then we have minus 1. All right, so I'm going to graph this. And where's my graph? Ah, there we go. All right, so it looks over here, and as you see, it's really easy on mine. On my calculator, I can easily identify my vertex, which is right here at that point right there. And it even tells me on this program that that's my minimum value. And it tells me my minimum value is there. But I want to go ahead and show you how to do it from your calculator, from your looking in terms of if you were looking at your calculator TI-84 on the that you get in hand. So if you notice, I have right here, I have -2, I have -2. And then just past that, I have 2 here. Well, if I look, I have 2 here, -1, -1. 2, 2, 7, 7. Okay? Those are what we call symmetric pairs. The point, -1, -2, that's the vertex. And I know it's the vertex because that's the point that will not have a symmetric pair. It's the only one that won't have a y value that repeats. Now again, side note, this is a function. It passes the vertical line test. Passes vertical line test. Okay? So all parabolas that are U-shaped or frowny face, they pass the vertical line test. Now, if we had a parabola that was looking like this, that would not pass the vertical line test, okay? But in the case of what we have here, we pass the vertical line test. The axis of symmetry, let's go back to this. I want you to look at my graph. Okay, so if I were to talk about the vertex being here, okay, my axis of symmetry, if I were to draw a line here at the middle, and I'm going to go, let me go back, let me do this, and I'm going to add, go to y equals, I'm going to add x is equal to, will it let me do this? It may not let me do this on here. I was trying to think if I could somehow change it, but it won't let me do x equals. I'm not sure how I can do a vertical line on the calculator. So we won't really be able to talk about that. But my axis goes, the vertical line, if that there, this point, -1, -2, is the lowest point. When I go over here, I have, let's see, let me get to 1. When I go over here to 1, or let's go here, 0, -1. When I come over here on this side, I'm going to have -2, -1. Okay, it matches. I have the thing about it. The y value repeats, but the x value does not. So it's a unique x value. Okay? So when that axis is symmetry, if I were to graph this, so let's go ahead and go to -1, -2, okay? That's my vertex. My axis of symmetry is going to go through that vertex, okay? Just like we did on the parent function, all right? Now, I'm going to have a coordinate point we said at 0, -1, and we're going to have another coordinate point at 1, 2. Okay, we're going to have a point there. Okay? Now, we can look at it as a table as well. We have x and y. We have a vertex at -1, -2. And if I were to plug in 0, okay, that would give me, 0, that would give me -1. Okay? So if I plug in 0 for x, that gives me -1. And if I plug in 1, let me look at my table. If I plug in 1, that's going to give me 2. Okay, so if I go over here to 1 and go up 2, that's that point that I just plotted there. Okay? So actually that should be over here, not there. I put it in the wrong spot. Because you kind of want, the idea is you want your numbers to mimic. So if this is my vertex, you want -1 to be on this side. So the y value here, because these two are going to match. And you're going to have 2 here. So those two are going to match. Okay? And then, so when we talk about this side, this is going to be the same distance. That's going to be the same the distance. Then we're going to go 1, 2, 1, 2, 3, 4. So that's going to be, we've got -2. That's going to give us -1. And then when we have 1, 2, 3, 1, 2, 3, -3, we're going to have 2. Okay? Now, if we notice, from our parent function, our graph shifted to the left and shifted down 2 units. Okay? Now, our domain is going to be all real numbers again. Our range is going to be y greater than or equal to -2. Okay? These are the main values that you're looking at, and your axis of symmetry is going to be the equation x is equal to -1. I'll do one more problem in the next video. I'm going to do 2 more problems. I'm going to do a problem that's a negative a value, and I'm going to do a problem where we have a value that's greater than